In this example, we'll be finding reference angles. Find the reference angle for 218 degrees. Let's begin by drawing 218 degrees in standard position. 218 degrees will land us approximately there, and therefore the reference angle would be the positive angle between that terminal side and the closest part of the x-axis. So I will call that theta. To find that reference angle, we would take 218 degrees and we would subtract 180 degrees. That would give us a reference angle which equals 38 degrees. Let's do another calculation. Find the reference angle for 1,387 degrees. Now with this, the first thing we'd want to do is to determine a coterminal angle that's between 0 and 360 with that angle of 1,387. So in this case, what we would want to do is subtract from the 1,387 degrees 3 times 360 degrees. This would give us 1,387 minus 1,080 degrees, and that would be equal to 307 degrees. Let's draw that angle in standard position. That would bring us all the way around to approximately here, 307 degrees. Now the reference angle would be the positive angle between that terminal side and the closest part of the x-axis. To find this angle, we would take 360 degrees and subtract the 307 degrees. This would give us 53 degrees, so the reference angle is 53 degrees. In this example, we'll be finding the trig function values of a quadrant 3 angle. Find the values of the 6 trigonometric functions for 210 degrees. We'll begin by drawing 210 degrees in standard position. So 210 degrees would bring us around to here. And now we want to find the reference angle so that we can create a triangle here. The reference angle, 210 minus 180, is 30 degrees. This is a right angle. That makes this angle 60 degrees. Now, when we label each of these sides, remember it's a 30, 60, 90 triangle. The hypotenuse is 2. The side opposite the 30 would be -1 to represent that y value. And this side, which is adjacent to 30, that would have to be negative the square root of 3. And it's negative because it's representing the x value. Well, now we can use that information to find the trig functions, starting with the sine of 210 degrees. First of all, in the third quadrant, the sine of the sine function is negative. So this is going to be negative, and we know that it's opposite side, which is the -1, over the hypotenuse 2. So the sine of 210 degrees is -1/2. The cosine of 210 degrees. Well, that would be equal to the side adjacent to 30 divided by the hypotenuse, so negative the square root of 3 divided by 2. Now we'll find the tangent of 210 degrees. That would be equal to the side opposite the 30 degrees, which is -1, divided by the side adjacent to 30 degrees, negative the square root of 3. Rationalize the denominator as well as divide a negative by a negative, and we find that the tangent of 210 degrees is positive the square root of 3 divided by 3. Let me bring in a clean sheet on which we'll find the other 3 trig functions. I've recreated the drawing, and we can see that I have my 210 degrees, my 30-degree angle, and my right triangle with the corresponding sides. So now let's find the cosecant of 210 degrees. That would be equal to the hypotenuse, which is 2, divided by the side opposite, which is -1. So the cosecant of 210 degrees is -2. The secant of 210 degrees, that would be equal to the hypotenuse divided by the side adjacent to 30, negative the square root of 3. Once we rationalize the denominator, we would have that this would be equal to -2 square roots of 3 divided by 3. And now we'll find the cotangent of 210 degrees. That would be equal to the side adjacent to 30 degrees, which is negative the square root of 3, divided by the side opposite 30 degrees, -1. Negative divided by negative is positive, so the cotangent of 210 degrees is the square root of 3. In this example, we'll be finding a trigonometric function using the reference angle. Find the exact value of the expression cosine -240 degrees. Let's begin by finding the coterminal angle that's between 0 and 360 to the -240. So that means we would have to add 360 degrees to the -240, which would give us 120 degrees. Now, drawing 120 degrees in standard position, it would bring us around to here. And now to find the reference angle would be the positive angle between the terminal side and the closest part of the x-axis. So it would be 180 degrees minus 120 degrees. The reference angle is 60 degrees. What we then say is the cosine of -240 degrees is equal to the cosine of 120 degrees, and that's equal to negative the cosine of 60 degrees, because cosine is negative in quadrant 2. And now, for the cosine of 60 degrees, we know that that's equal to 1/2. So negative the cosine of 60 would be -1/2. So what that tells us is that the cosine of -240 degrees is equal to -1/2. Let's work a similar example. Find the exact value of the expression tangent 675 degrees. We'll begin by finding a coterminal angle for 675 degrees. To do that, we would have to subtract 360 degrees, giving us a result of 315 degrees. So that's coterminal with 675. To draw that angle in standard position, we begin here and come all the way around to the fourth quadrant, and that's our angle of 315 degrees. The reference angle would be this angle between the terminal side and the closest part of the x-axis. We find that by finding the difference of 360 degrees minus 315 degrees, giving us 45 degrees. Now we're interested in finding the tangent of 675 degrees. Well, in the fourth quadrant, tangent is negative. So we have to keep that in mind because we know this is equal to the tangent of 315 degrees, but then that's equal to negative the tangent of 45 degrees. From our knowledge of 45 degrees, we know the tangent is equal to 1, so negative tangent 45 degrees would be equal to negative 1, and that tells us that the tangent of 675 degrees equals negative 1. In this example, we'll evaluate an expression using function values of special angles. Evaluate cosine 120 degrees plus 2 sine squared of 60 degrees minus tangent squared of 30 degrees. Let's begin by writing down the trig function values for those three. That is the cosine of 120 degrees. That is equal to negative 1/2. This angle is in quadrant 2, and so cosine is negative, and it's using the reference angle of 60. Now the sine of 60 degrees is equal to the square root of 3 over 2. And the tangent of 30 degrees is equal to the square root of 3 divided by 3. Now we'll substitute those values into our expression. So this is going to be equal to the cosine of 120, negative 1/2, plus 2 times the sine of 60 squared, so square root of 3 over 2, all squared, minus the tangent of 30, the square root of 3, divided by 3. So now and that's also quantity squared. So now let's simplify. We would have negative 1/2 plus 2 times. Square root of 3 over 2 squared is 3/4. Minus the square root of 3 over 3 squared is 3/9. Simplifying further, we have negative 1/2 plus, here we can cancel, and we have 3/2, and here we can simplify 3/9 to 1/3. When we subtract and add those numbers together, we have a total of 2/3. That's the value of the expression once we substitute in the known special angle function values. Evaluate cosine 780 degrees by first expressing it in terms of a function of an angle between 0 degrees and 360 degrees. So what that means is we need to subtract 360 degrees enough times from the 780 degrees in order to make it an angle between 0 and 360. And that means we need to subtract 360 twice, which is to say that the cosine of 780 degrees will be equal to the cosine 780 degrees minus 2 times 360 degrees. Well, 2 times 360 degrees is 720. 780 minus 720 is equal to the cosine of 60 degrees. And then we know from those angles that we've memorized that the cosine of 60 degrees is equal to 1/2. And that means that the cosine of 780 degrees also is equal to 1/2. Let's work another example. Evaluate cotangent of negative 405 degrees by first expressing it in terms of a function of an angle between 0 degrees and 360 degrees. So we need to add 360 degrees to the negative 405 degrees enough times to get it to be an angle between 0 and 360. So we need to add twice, that is 360 degrees times 2. So we write that the cotangent of negative 405 degrees is equal to the cotangent of negative 405 degrees plus 2 times 360 degrees. 2 times 360 is 720, added to the negative 405 is equal to 315. So this would be equal to the cotangent of 315 degrees. The reference angle for 315 degrees is 45 degrees. 315 degrees is in quadrant 4, and the cotangent is negative in quadrant 4. So we now write that the cotangent of negative 405 degrees is equal to the cotangent of 315 degrees, which is then going to be equal to negative the cotangent of 45 degrees. And that's equal to negative 1. So the cotangent of negative 405 degrees equals negative 1. In this example, we'll be finding angle measures given an interval and a function value. Find all values of theta if theta is in the interval 0 degrees to 360 degrees and cosine theta is equal to negative the square root of 2 over 2. Let's start with the idea that cosine is negative. We know that cosine, which is the x value over the r, would have to be negative in quadrants 2 and 3. So the angle we're looking for is in the interval from 0 to 360, more specifically in quadrants 2 and 3. Now let's think about what angle that has a cosine equal to the absolute value for the square root of 2 over 2, or negative the square root of 2 over 2, which is then positive square root of 2 over 2. That would be the reference angle 45 degrees. So now we want an angle in quadrant 2 that has a reference angle of 45 degrees. Let's draw 45 degrees as the reference angle. So to find the angle itself, we would take 180 degrees and subtract 45 degrees, which gives us 135 degrees. So one possible angle for theta is 135. Now let's do the same thing in quadrant 3. We draw a reference angle of 45 degrees. To find the full angle, whose reference angle is 45, we would have 180 degrees plus 45 degrees, resulting in 225 degrees. Therefore, theta is either 135 degrees or 225 degrees.